In this video clip, we learn dummy variables in regression. A dummy variable is a categorical independent variable with two levels, such as yes or no, on or off, male or female, coded as 0 or 1. We assume equal slopes for other variables. If there are more than two levels in a categorical independent variable, then we need to use more dummy variables. Specifically, the number of dummy variables needed is number of levels minus 1. We will explain this later. Suppose in our pie sales example, we have a new variable x2 holiday. x2 is 1 if a holiday occurred during the week, 0 otherwise. So here we have y hat equals b0 plus b1x1 plus b2 times 1 for a week with at least a holiday. Then we have b0 plus b2 here plus b1x1. For weeks with no holiday, we have y hat equals b0 plus b1x1. We see different intercepts, same slope. If the null hypothesis beta 2 equals 0 is rejected in the corresponding t-test, then holiday has a significant effect on pie sales at a given significance level. For example, if we have such an equation, then 15 means that on average, pie sales were 15 greater in weeks with a holiday than in weeks without a holiday, given the same price. Now we see the case where a categorical variable has more than two levels. Here, the number of dummy variables is 1 less than the number of levels. Let's see this using an example with y variable, house price, and one independent variable, house size in square footage. In addition, we have another independent variable, the style. The style has 3 levels, range, split. So here we need 2 dummy variables. You may wonder, can we use one categorical variable with values 1 for range, 2 for split level, and 3 for colonial to model style? The answer is no. Here, the 3 styles, range, split level, and colonial, have no numerical or quantitative relationship. If we use 1 for range, 2 for split level, and 3 for colonial, then whatever parameter for range, we have double coefficient applies for split level and triple coefficient applies for colonial. We don't have such relationship we know of, or we cannot assume such a relationship. So we have to use 2 dummy variables to model style with 3 levels. We can use colonial as the reference level or default level. Then we define x2 equals 1 for ranch and 0 otherwise. X3 equals 1 for split level and 0 otherwise. So we can see if X2 equals X3 equals 0, then the style is colonial. It is infeasible to have X2 equals 1 and X3 equals 1 simultaneously. Suppose we have a multiple regression equation as follows. And further assume we have such a regression equation. Then we have for a colonial house, y hat equals this term. Next, for a ranch, we have y hat equals this term. It means with the same square feet, a ranch will have an estimated average price of $23,530 more than a colonial. Finally, for a split level, we have such an equation. It means with the same square feet, a split level will have an estimated average price of $18,840 more than a colonial.